A homecoming day parade float is traveling at 2.5 meters per second. The gas pedal gets stuck on the floor and the float accelerates for 500 meters before reaching a final velocity of 45 meters per second. How long was the float accelerating for, and what was its acceleration? If the float then slowed to a stop in 50 more meters, what would be its new acceleration? Be sure to check your sign. So, let's get started. Our equations that we're going to be using are s equals xi plus vit plus 1 half at squared. And a is equal to vf minus vi over t. Our variables, of course, are then s, xi, vi, vf, a, and t. And that's going to be in our part A for A and B. And then we're going to have a second part cover C. S, Xi, Vi, Vf, A, and T. Okay, what do we know? We know that it starts traveling at 2.5 meters per second. We know that when the gas pedal gets stuck, it's accelerating up to 45 meters per second. And it goes, its motion goes on for 500 meters. Our xi, we're saying, is going to be 0. We're going to start at our reference point, so that'll make things nice and simple. And we want to know the time, the acceleration. So this is part A, this is part B. Then we'll get to part C after we find those. So we're going to set this up the same way we set up the last problem. We've got all of our variables except for A and T, which is going to prevent us from solving anything directly. So we need to set up an S equation that substitutes the A. So S equals xi plus vit plus 1 half at squared. And we're going to say A is equal to Vf minus Vi over T. And we're going to put that in right there. Rewriting it is S equals Xi plus Vit plus 1 half Vf minus Vi over T squared. Now remember, that simplifies. Get rid of the T, get rid of the square. You still have a T here, but at least you don't have a square to deal with. Our S is going to be 500 meters. Our xi is going to be 0, so we're just going to drop it out. We're not even going to work with it. Our vi is going to be 2.5 t plus a 1 half vf minus vi, so 45 minus 2.5. All of that times t. So 45 minus 2.5, and then divided by 2 is going to be a 21.25 plus 2.5 t equals 500. Now, let's go ahead and merge these two, because we can. It's going to get us 500 equal to 23.75 t. To find time, I just divide both sides by 23.75. It's going to get me 21.05 seconds. There we go. There's part A. Okay, and now to find acceleration, we just plug this number back into our acceleration equation. So doing that really quick, I'm just going to use this space right here. That's going to be 45 minus 2.5 over 21.05. That will give me an acceleration of 2.02. Writing that in, 2.02 meters per second squared. Now let's move on to part B. Or part C, I should say. We're going to have to end up doing the exact same thing for this, because now we're going to set up a new reference point, because it's a basically whole new problem. We had our float traveling 500 meters with a certain initial velocity and a certain final velocity, and it had a certain acceleration. Now we're going to say in 50 more meters, everything else is happening. Most of our things change. So at this point, our initial velocity is going to be the same as our final velocity of the previous problem. And because I'm not asking you to tell me anything about this total distance here, it's actually going to behoove you to set up a new reference point right there. So that's our starting position for part B. So our reference point and our starting point are the same. So xi is 0. Our s is 50 meters because it's taking another 50 meters to stop. Our vi is going to be our velocity final of the previous problem. So that's going to be 45 meters per second. And our vf, notice, slow to a stop. That means our vf is going to be 0 meters per second. Now, my acceleration, when it is slowing down, what does that mean about my acceleration versus my velocity? They have to be opposite signs. So in the first part, I was speeding up, so I had a positive acceleration. In the second part, I'm slowing down, so I'm going to have a negative acceleration. So I want to keep that in mind. As we go through this problem, our numbers should come out negative. So, once again, we're missing a and t. So I'm going to go ahead and write out my s equation with the acceleration equation already substituted in. Save myself a little bit of time. VIT plus 1/2 VF minus VI over t squared. Then dropping the t's, so I get s equals xi plus VIT plus 1/2 VF minus VI t. Beautiful. Now let's throw our numbers in there. My s is going to be 50 equals xi is going to be 0 plus VIT 45t plus 1/2. Velocity final is 0. My velocity initial is 45 t. All right. So, simplifying this down, 0 minus 45 is negative 45, divided by 2 is going to be 22.5. Plus 45t equals 50. 45t plus a negative 22.5t, because these terms are the same, I can just merge them together. And negative 22.5 is half of 45, so we're going to have 22.5t. A positive 22.5t equal 50. All right. That's going to give us a result of 2.22 seconds. Now that is the correct sign on time, because it always has to be positive. Now, what is the acceleration? Plugging this number back into my acceleration equation, A is equal to VF minus VI over T. VF is 0. VI is 45 divided by a positive 2.22. Going to be equal to a negative 20 0.3 meters per second squared. Beautiful. So my acceleration in the second part is a negative 20.2.3 meters per second squared. That looks great. Thanks, guys.